first time when we are in Russia as travelers and as speakers, and we are very happy to present at TestCon. And we wanted to thank organizers and program committee for inviting us for this conference. We are really happy to be here. I'm Ewa.
I'm Kamil.
We work in the same company, which is Allegro, and we work in the same project, which is a mobile application for iOS for buyers. It's like Amazon or eBay. It's an e-commerce app where you can search, display, buy, and pay for goods. Right now, we are in the top 7 in the shopping category in Polish App Store. And we have around 500,000 unique users per month.
So again, we think that tests, just like onions and ogres, have different layers. We start from the most inner layer, then slowly go to the most outer ones. So the most inner layer, in our opinion, is writing your code, and the most outer one is distributing the applications to the user and installing it from the App Store. We won't be speaking in details about the tools, because you can always find them in the documentation. Instead, we have chosen 8 real issues that we faced during the development of our project and how we solve it on different layers of development. We wanted our presentation to be possibly generic, which means that examples and ideas that we include would be applicable to any other platform or programming language. We are aware that not everybody in this room had a chance to develop application for iOS system. As you could see, there are a lot of test layers. You may wonder why we try so hard to avoid bugs in our applications. As not everybody may be familiar with the difference between web and mobile releases, I will briefly outline the difference. So, when you fix something on the server, on the backend, all of the users instantly have the newest version in the web browsers with the fixed setup. But there is a different story on the mobile. First, you need to upload your new app version to the App Store. Then you wait for the review, approximately 2 days. And when your app passes a review, you can then release it to the users. But you need to wait approximately 1 week to reach 90% of the users. So this is a lot of time, especially for critical bugs.
Okay, so let's start with our testing onion, and let's start with the first layer of testing, which is about static analysis. So this is exemplary code. It's written in Swift. This is the language that we use in iOS projects, and it's not production code, don't worry. It's just to illustrate the problem that we experience in our project. So this fake function, find family related category, is just find category that is related to family. It first checks whether the category name is non-empty, then it checks the name, if it's equals to children and baby, or toys and games. Then it checks if the category was already found or not. There are also 3 else statements being handled within this function. Do you see something suspicious here? Something smelly? Something that maybe is... I'm sorry? Yes, this is quite complex. There are a lot of ifs, like it's really like 3 nested ifs and 3 else statements. It's quite a trivial problem, but the code is quite complicated. So this is the issue that we are handling in our project. At this complex code, we are very unhappy to learn that this kind of complex code was passing through our code review level. And we knew that it's really bad because the code review's quality is not enough. We knew that we don't want to handle such a code in the future, because this kind of code smells does not have to necessarily cause bugs. But definitely this kind of code is hard to read, hard to test, refactor, and maintain. And in projects like ours, we need to be ready for maintaining code for some time at least. So we were thinking how we could prevent such a code smell in the future. And some days ago, Kamil sent me this picture that I think reflects nicely the problem. This is the very first release. Your code is really sweet. It looks like a kitten. But after some unplanned changes, holiday commits, and refactors, it's becoming a monster. So, if you want to take a picture, I really like this picture. So this is a really cool turnoff.us. It's a really nice web page with the comics. So we didn't want to create monsters like the previous one, so that is why we started using Sweetland, which is linter for Swift. So I'm quite sure that most of us are aware what linter is, but just to be sure that we are talking about the same, could you please give me just short definition of what linter is?
Yes, please.
Yep. So it reports the violation of style policy. It also marks some suspicious constructs that are likely to be bugs. So this is exactly linter. And of course, we didn't Swiftland all the things at one time, but we did it as following. Swiftland has a configuration file, which is like, this is the example of it. It's a swiftland.yml file, where you can configure your linting rules. First, you can exclude some of the files you don't want to lint, because they are, for example, external libraries that you do not support, maintain. Then you can disable some of the rules. There are around 120 rules in Swiftland, and 70 out of which 70 are enabled by default. So we started with a default set of rules. We wanted to start with the most common ones. And then we ran the linting procedure, and we found out that some of the rules are not critical for us. We don't want to fix all of the violations at what time. That is why we disabled some of the rules, like this one, identifier name. This rule was giving us a lot of violation because the naming of constants in our project is not perfect. You can see like ID. It does not say a lot about what the constant does. We also have a lot of really long names, like this one. It's browse category button container 0 with constraint. It's really long. We know it's really bad, but we have a lot of names like that in our project. I'm not sure how it looks in your project, but sometimes names, as you can see, are definitely not perfect. And we knew that there is a metric called cyclomatic complexity that measures the complexity of the code that I was talking about before. So we were really happy to use it in our Swiftland configuration file, and we were using the values of 7 and 10 that were causing warning, so you could still build your project, but you were warned. Okay, there is something going on, so you may be willing to fix this, and 10 is a number for error, so you are not able to build your project. The default values for these two is 10 and 20, so we used the more strict values because we knew that we have a problem with the complex code, and we want to monitor this issue. So as soon as we were talking in our project about linting, we were thinking that maybe instead of only marking some of the violations, maybe we could format some of them automatically. So this is how we started using Swift format, which is code formatter for Swift. So we thought that maybe some of the obvious rules can be not only marked, but can be formatted so developers do not have to bother. And we also got some configuration, and Swift format is also configurable. So you can, for example, configure some of the rules like this one. So you are, for example, stripping the header because we find it's not that useful. You can also, for example, remove the commas that are in line, and you can also disable some of the rules that you don't find useful. For example, we don't want to format the numbering in some specific way. So it also can be configured. So here are some remarks on our linting and formatting procedures. So we use the same version of formatter and linter. They are stored in our repository, so developers have the tools ready to go. They can just check out our repo, and the tools are already there. At the same time, we are also sure that we use the same version of software, the same version of rules, so we will not have the difference between rules versions. We also run our linting and formatting procedure locally. It's a part of the build phase, so every time you build the project, formatting and linting appears locally. At the beginning, we did it on our CI server, but it significantly, maybe not significantly, but it prolonged the build time up to 5 minutes, which for us was kind of problematic because we know that we already have a problem with the build time because we would like build time to be shorter. So we decided that it is developers' responsibility to run it locally. And we have a rule that we format obvious rules and we lint less trivial rules, meaning we give a developer a space, so if he thinks that it should be fixed, he or she can do it, or if the developer thinks that, for example, this rule is not useful, this rule can be disabled, like the rule with the identifier name I showed you a few slides before. And we also apply the linting and formatting not only for production code, but also for tests, because we believe that tests quality is also very important. Okay, this is how we solve the problem with the complex code with some static analysis tool. Let's move to the second problem, which is about mutation testing. Have you ever heard about mutation testing before? Great. So again, this is exemplary function. Fortunately, it's not our test code. I would like to ask you if you see something suspicious going on here in this test. It creates some constants, a and b, then the third constant sum, and it asserts whether the sum equals to 3. Do you think this will pass?
Yes.
Why do you think so? It's a correct answer.
It's always pass.
Exactly. The problem here is that it will always pass. We call these kind of tests evergreen unit tests because what you can see here, these are two constants, but the sum is not like the results of like the equation. It's just like we say, okay, this constant sum is equal to 3. So we do not check the actual logic. We just check whether the constant is equals to 3. So we got this problem in our project, especially as far as we were using ObjectiveC and mocking libraries. We were sometimes over-mocking. So we were mocking so many things that the test did not check application logic, but it was just passing green. Of course, green tests are very beautiful and we really like them, but it's not the point. I think we all agree on this. So we were thinking how we could prevent this situation in the future, and this is how we came up with mutation testing. So I know that some of you have heard about mutation testing before. Just for the recap, we have a function and the tests for this function. Then we intentionally introduce some changes, some mutants to the code. So instead of beautiful horse, we have this creature. And then we run our tests again. If the tests will detect mutants, they should fail. It means that the tests are checking application's logic and they detect that something has changed. But if the test will pass, it means that they are evergreen unit tests and something is wrong here. So no mutants should survive ever. Our tests should always detect it. Here are the examples of possible mutations, very simple ones. So for example, instead of returning true, you can change your function to return false. Run your tests and check whether it will detect this mutation. You can also negate some conditions. So instead of value that is equal to null, it should be different to null. Again, tests should detect it. And then you can change some mathematical operator, like for example here. These are only examples. You can do actually anything you want in your code to check your tests. And again, we have some conclusions on test mutations. We learned that code coverage says little about tests quality, because even though the code coverage will be high, sometimes the tests are not useful because they are not checking the application's logic. So mutation testing helps you to learn more about the quality of tests. We also, right now we use manual mutations for non-trivial test cases. So every time we feel that our test is a bit complex and it's possible that we could make a mistake somewhere, we try to test our test with mutation tests. It's quite complicated, but it really works. And we also know that not all of the mutations add value. So we know that some of the mutations will not be reflected by actual users on production, meaning that we can create artificial fake mutations that will not have a chance to appear on production environment. So it's also important to remember about that. And we also want to research a project called Mool, which is about automation of mutation testing, and it seems to be very attractive, and we would be really happy to apply it in our project, but it's still in the research stage. So every time I see the green test report, I'm thinking about the code that I wrote, if it's really so great, or the unit tests that are quite shitty.
All right, so we know everything about the mutants, so let's get familiar with snapshots. You probably know what is a code review, and hopefully all of your changes go to review. So for the recap, this is the standard code review page. In our case, this is the stash. You can see all the changes, file modified, changes in code, and you can comment on it. But what if we complicate it a bit? So maybe anyone knows what this code represents? You can guess. Okay, it's hard to read, but this is kind of XML. It is storyboard format used to lay out views in the iOS, in the Xcode. So you can have this kind of view on the review, and you wonder what happened here. And in this case, it's really easy. It is just a cell for single item. And you wouldn't wonder what is it. So how to make it easy to review? Solution for this problem is recording actual view into the image during the unit tests. It's called our reference image. So now when I create a pull request, it will not only have storyboard with XML format, but also include an image. In this case, you can see cell with the price. Then after some time, for example, Ewa changed this cell and removed the price. So now it's really easy to see what actually have been changed. And the difference between the reference image and new image is our div image. It only contains the changes that have happened. So stash have this great view, so you can have the new overlay and you can really easy move it with your mouse. You can have more than one image for one view. For example, we have a lot of them for different font sizes and different device screen sizes. And now, no special knowledge is required to perform code review. In our case, even a graphic designer can join. He has the most knowledge about the UI and can spot the mistakes during the code review level. So, for the recap, value your time. 5 different devices with 2 different screen orientations and 5 different font sizes equal to 50 cases to check. So that's a lot of time you can save. Spot visual mistakes on code review level. It's a lot easier to look on the image than on the code. And you don't need to build the application. And involve testers and designers into the review. Make code review accessible to anyone. Designers can only look into the snapshots.
Okay, so this is how we dealt with the problem of reviewing UI-related code with the snapshot tests. Let's talk more about functional tests right now. So in Allegro company we are working in, we work in a complex environment. I think this is the case of every bigger company. So there are many people working on many features simultaneously, and change is our bread and butter. This GIF is a little bit blurred because it reflects actual production data, so for the security reasons I was asked to blur it a bit. But it shows a part of our microservices structure on production, because our application consists of around 500 microservices that are exchanging around 25,000 events per second in the peak time. So there are a lot of events, a lot of changes, and many things to handle. So as I said, change is our bread and butter, and by change I mean, for example, new feature being introduced or some bug fixes are being introduced. And sometimes, because the system is so complex and communication is not always perfect, it's sometimes hard to predict the consequences of change introduced in one place that may have an impact, for example, on our mobile application. There were a few cases that our mobile application stability suffered because somebody did not think about influence that change may have on our mobile app. And we were thinking how we could prevent such a situation and how we could monitor this kind of situation in the future. And this is how we came up with a set of end-to-end UI tests. So they were the tests written in ObjectiveC using KIF framework, which stands for Keep It Functional, as external library. So they were a set of tests that were communicating with the actual API, and they were run every night, and they were giving us information and if everything is fine, or whether something is wrong, the test results are read, and we should react accordingly. We knew that these kind of tests are dependent on many factors like internet connection or API stability. So we knew that they may perform a little bit slower. That's why we put them in a separate test suite, test target. Target is like the name for the Xcode, so for the iOS project. And we were very unhappy to learn that some of the tests are flaky, meaning that they are failing randomly, regardless of the application's logic. We don't like flaky tests because they hinder development and they hide real bugs. And we are thinking, what should we do with them? And what we did, instead of using end-to-end UI test communicating with a real backend, we created a set of functional UI tests with a mocked API. What does it mean? It means that the application that is performing tests, instead of calling the actual API, it uses saved responses. So what we did was we recorded all the requests that application was performing during the tests, and we saved JSON responses in our repository. In this way, tests did not have to connect to the backend. They could use the JSON responses that were stored in our repo. In this way, tests could actually work offline because they didn't need the internet connection, and they were like independent of many factors like internet connection and backend stability. So we were happy to have more reliable UI tests. We knew that this kind of approach brings one risk. What if something changes in the backend and we will not change something in our JSON responses stored safely in our repository? We knew that we need to handle that risk, and that is why we created scheme validation. So having our JSON files stored in our repository, based on this information, we create JSON schemes. Scheme contains information about response structure, variables presence, and their types. These two are input for configuration file. So configuration file contains information, what we expect from the API. Then we compare this information with the actual backend requests, and we check whether our expectations versus reality, if these two information are consistent or no. If these information are consistent, our validation passes, and we are sure that our API data is up to date. It's just to understand better the idea, this is the example. So in our JSON file, we have information about auction, which is active. Based on that information, we created a schema, which contains information about presence and the type of the part of the JSON. So we know that this is a string, and from our knowledge and experience, we know that the auction can not only be active, but it can be also ended. This is the enum value. So the auction can have one out of these two values. We have our configuration files that contain information about JSON and schema, and then we make the actual backend requests. And we get information about auction that is finished. What do you think will be the result of remote validation?
It's very clear.
Yes, because?
Because not as much enumeration, not as much value.
Yeah, because we got information about auction that is being finished, and possible values that we expect are active and ended, meaning that something has changed in the backend. It means like the field's name is a bit different, and validation will fail. So what we should change here, we should update our schema, and instead of ended, we should put it finished should be information about finished should be included in the schema. Of course, we should also update our application because there was a change that probably will have an impact on application behavior and appearance. So we were happy to have faster and more reliable UI tests because they were independent on internet connection and backend stability. But in the same time, we noticed that our test coverage progress slowed down because not only we had to write tests, but also we had to stop the responses, validate the schemas. So this process was a bit longer and it takes a little bit more time. Our UI test suite is also run after every merge to the develop branch, but it's not critical to merge. So sometimes as developers we tend to forget about running them before merge, and we sometimes forget about updating them. And it is also the issue we are struggling right now, how to make our tests unforgettable. I told you about being less flaky and more reliable. Here are some qualitative analysis that we performed. What we did, we compared 10 test runs between tests using real API and tests using mocked API. And we learned that tests using mocked API are definitely less flaky, and they are discovering more bugs. So we were quite happy with this qualitative measurement.
Yeah, numbers speak for themselves. So let's talk about continuous integration. With unit tests run with every pull request, we have continuous check if our project is in working state. So no working changes will not be merged into our repo. We say we have some kind of guard that checked us for us. But this only checks code covered by tests. As we know, green continuous integration doesn't actually mean a bug-free state. Like with this train, we can focus only on checking if the train is running, but we couldn't see that the rails are missing. In our case, we have thousands of unit tests that can pass, but during the regression, we can find many obvious mistakes that will need to be fixed and will slow down the release. Problem is how we could get instant feedback on the current app state, because it is impossible to perform manual regression tests every day. So there is this term called dogfooding. It means feeding your employees of company with beta version of your applications. So we distribute it with Apple provided test flight, and user need only to provide us with email address, and then he will join our beta testers group. When he joins, the beta version replaces the production one. Now he will use the application just like normal one and report any bugs or mistakes to us. We have special HipChat channel, it can be Slack or special mail, so you can have instant feedback from your company employees. Thanks to that, we can spot the obvious mistakes much sooner and fix them before they hit the production. So, get as many testers as possible. You can try to convince users to join by giving some free swag, or you can challenge them to get more bugs reported. And highlight what should be checked. Good release notes can help users to focus on particular part of your app and automate your beta releases. So what we can tell you from our experience is if you have painful beta release process, for example, manually doing it, it will be hard to continuously deliver new version every day. You can check out Fastlane tools for automation of beta releases. You may find next topics similar to dogfooding, so let's move to phase release. So we have added asynchronization of locally stored data, functionality that users ask us about many times. We spent some time carefully testing different cases, and after the release we check the App Store. And we see this comment, like the application won't start after the update. And turns out we have heavy users that have hundreds of records to migrate, and this causes the application to crash. It was hard to anticipate and prepare test data for that case. So there are some cases that you cannot simply predict, but how can we minimize the impact of them? So when releasing the application to App Store or Google Play, you can select a phase release, meaning that updates roll out only to the part of users. In this example, on the first day, only 1% of users will get new version. Then we carefully observe if any problems will surface. If so, we can stop the update and create hotfix. If there is no problem, we can then move to another day and more users get new version. But beware, when you reject the update, the users that have already new version installed, they will stay on this version. So there are situations you cannot predict, so better prepare for failure. So instead of focusing on finding bugs, try to find solutions to minimize impact for them. And remote configurations. Because update cannot be reverted, it's a good idea to hide risky features behind the feature flags, so you can always turn them on and off in case of failure. Keeping in mind remote configurations, let's talk about A/B tests. In our company, specific kind of tests are tests of our hypothesis. We wonder, if we change the Buy Now button from red to green, will we have more purchase? There is no simple answer. So we would like to know how different options perform for our users. And this can be solved with A/B tests, which means our users will make a vote. A/B test is controlled experiments with 2 or more variants. We use a tool called Optimizely. It is available both for web and mobile, and it's really easy to perform A/B tests with it. In our case, we have different users, and depending on which group they are assigned, they will see red button or green button. You can specify the groups, for example, by the device or by the country. And after some time of running tests, you can see the performance summary. In our case, we see the original button, which performs like normal button without any change, and new one, green button, it has a lot of more purchase. So we now know that green button is better option for us. And thanks to all the effort, we can now make decision based on data, not on our opinion. Beware, always check the default values. This is actual screen from the Twitter app, and as you can see, user have only 20 characters to tweet. And so he knows he's in bad A/B tests. And fun fact, there could be a lot more options than A/B. There are over 60 Facebook Tabbar variants reported by the users.
Okay, last but not least, let's move to the last layer of our testing onion. And some time ago, we released an app version that contained changes of navigation through products categories. We were quite happy to notice that the version was quite stable. We didn't see any significant number of crashes that we measure with our tool that is called Crashlytics. It's produced by Fabric, and it just gives you information about application stability. But then we saw comments on App Store saying, "Where's categories button? I cannot find it." Of course, we were very sad because we thought that the change that we introduced will be enjoyed by the users. Apparently, it wasn't, because the users could not find the button. And we were thinking, what shall we do next? How many users are affected? do all users cannot find categories button, or only 3 that wrote the comments? Should we revert our changes or create some bug fix? We were quite emotional about it, but instead of getting emotional, we started to use data. We have analytical data that informs us how users use our app. So instead of making decisions based on emotion, we decided to turn into data. And this is some small analysis about how the users were using the new categories button. So this is the release date. So we see that here the users are starting updating the app and using the button. In case of our application, it takes around 7 days, as Kamil said before, to update the application by around 90% of the users. So after around 1 week, we could notice that the usage of the button was the same as it was before. So we knew that probably we did a usability mistake. We should test with users this feature more carefully, because the users could not find the button. So it definitely was our fault. But the analytical data helped us to make decision whether we should revert the change, or maybe we can just wait that the users will notice the change and they will be able to adapt. So based on analytical data, we are able to do more database decisions, and we can estimate bug priority and severity. And we always try to analyze and plan our reaction instead of reacting emotionally and, for example, reverting the changes in panic. Thank you very much for getting through all the test layers with us. We are very happy that you were with us today, and we hope that you found something that can be applicable in your project, that you found useful. And we want to emphasize that our testing onion is still evolving, and we have many problems still unsolved and many issues to address. Thank you again. We'll be happy to answer your questions. Yes, please. You want to slide down?
Do you do some kind of field tests?
What do you mean by field tests?
Like you take the device and you go to the country, some country that you cover, and you actually check if it's working correctly in this country or with this quality of signal on the device?
This is a very good question, especially as far as mobile testing is concerned, because we are testing in laboratory conditions, sitting by the desk, having great Wi-Fi connection. So it's really hard to reproduce the real life scenarios. And as Kamil was saying about dogfooding, we all have the beta version of our app installed on our phones. So when I'm doing my personal shopping, I also use Allegro. So I do it at home, when I'm traveling by train. And we also, as a tester, I tested like in my regular shopping. So we definitely try to go outside of the office and avoid these laboratory conditions, because they are definitely not the ones the users are using. So we definitely try it.
Thank you.
Thank you.
You were talking about how you have a JSON, like a
JSON schema?
JSON schema and the JSON responses that you test through. So say, for example, you have in your tests, you do an action that actually changes something on the back end. How do you test that?
This is
I mean, if you have a stashed response, maybe that process of changing from one state to another doesn't happen on the back end.
This is another good question, because as far as requests that change the server state, we do it only locally, because I show you validation, and we have like remote validation that is making the request to actual backend, and we have also local validation. We use local validation for the requests that are changing the server state, because as you said, for example, you want to buy an item, so it changes it's finishing the item on production, and we don't want to do it. So right now we are doing some local validation, so we know that it's not that good as calling the actual remote, but this is our solution for now. Do you want to add something maybe to?
That's okay.
Does it answer your question?
Yeah.
Maybe please.
Thank you for your presentation. One question. Could you please say something about the pain that you apply the practice of linter in your QA, especially in your QA side? Do you feel some slowness in the applying of this practice, or maybe some lack of qualification from QA side or something like that?
So if I understood correctly, does linting procedure influence the time of testing or the time of building?
Time of testing and maybe time of learning how before the teaching the QA specialists or something.
I find linting and formatting procedure as a help for a tester, because you are able to detect some violations even before you run your test on device, because it's a build phase. So even before you run your application on device, you are informed about violations of code style and code quality. So for me, it's a help, and as a tester, I also participate in configuring the rules and detecting some violations.
But as I understand, you apply it also for the already written tests, so not only for you. So you refactor the old tests, and it's a time-consuming thing.
Yes, it for sure takes time. That's for sure. But I believe it's an investment. So it will give us some information about code quality, and it will result in a better knowledge how our code looks like. So I treat it as an investment.
Yeah, and Sweetland, for most of the rules, have option to automatically adjust for the changes. So you can run it once with the flag autofix, and you will have most of them fixed for you for free.
Do you do most of your testing on emulators and simulators, or do you do most of it on the devices? Do you find a benefit to either one?
As far as iOS is concerned, we only have simulators. There's iOS simulators. Unfortunately, we don't have emulators. Of course, we know that testing on device is the best option. So right now we are experimenting with testing on devices and testing on our farm, like testing farm. So we have many devices connected to one hub where you can write test runner that runs the test on every single device, but it's still in a build phase right now. But we would truly, we would be really happy if it would be working very without
it's work in
problems.
progress, but it's work for Android. There's like 20 devices connected to one server, and it runs with remote preview and stuff like that.
So we are definitely going into that direction. Okay.
Do you automate your upgrade testing?
Upgrade? Yeah. So before every release, we have set of regression tests. Some of them are manual, some of them are automated. So one of the manual test cases is to check whether the application update did not change anything, so it did not cause any bugs. We find it especially important. It's because the App Store version, we experience situations like that the new update causes some bugs, so we definitely pay attention to update testing.
Just manually?
Yes, for now manually. As far as I'm concerned, it's quite hard to automate it, but probably it would require some more work on our side, because I don't know any tool from Fastlane or from any other source.
No,
so it probably
not so popular. Like everybody tested manually.
But if you would know something, I would be happy to talk later, because it's also a very interesting issue.
Thank you very much. The time for session is over. Unfortunately, this is some nice discussion. We can finish it during the lunch break or during the coffee break. And we're really glad to host you here. And this is our little gift from
Thank you.
Moscow.
Спасибо.
Thank you very much.